in some of the jobs, some of you might have seen it done in the past. Sometimes we miss gauge. An open leakage here. Thank God that the building, because the moment water enter all those DC cable, they start getting rust. And when they start getting rust, they turn to like powder. They will not allow enough current to flow through. So you must make sure that at any point you are joining wires, you do what? Use enough tape. Maybe we call it masking tape. It might be black tape, it might be red tape, it might be. Make sure that you use enough tape to hold it. That's for the cable. Against next classes, you guys will have done your research. We discuss better. Next one, we have what we call MC4 connectors. MC4 connectors. This is what an MC4 connector is. MC4. There are some installation you do for some organization like MTN, like HIS, when you are working on their side. They will not allow you to join wires together. You must use connectors, MC. Under these MC4 connectors, we have MC6. Then we now have MC4 loops, where it can have 2 input, 1 output. So instead of joining 3 wires together, you use 1 male and 2 females. And note one thing, your positive will normally have male at the terminal end of your panel, while your negative will have what? Female. And positive, what is the color of positive? Red or brown. Red or brown. Your negative can be black or blue. Your positive is red or brown. So this is the male MC4. This is the female. But in some job, we normally just cut the wires and join them together. Make sure that they are well. The way they pray, say they no talk. The next one, what you go do? You go born. You don't say amen. Oga no even talk. Oga deeper like I no even talk amen. No problem. Let them hear. So this is the male and this is the female. We have the MC4 connectors and we have those loops that you can use to blend them together. Can I move on? After that, we have what we call the protective devices. You know, I'm listing the components that makes up solar panel and inverter systems. We'll still go deep into them. In your protective devices, we have circuit breakers. It might be DC. You know, if it's DC circuit breaker, it means it can accommodate higher current and lesser voltage. If it's an AC circuit breaker, it can accommodate higher voltage and lesser current. We have the breakers. After the breakers, we have what we call the surge. You know, surge, you have multiple inputs and has only one output. And that output is always connected to the acting of your building. We have the surge. Surge allow excess energy that is coming in. Instead of spoiling any of your devices, we pass through the surge and sync them to the earth. After surge, we have the next one we call isolators under protective devices. There is a difference between a breaker and an isolator. In breaker, the moment it notices any fault along the line, what will you do? It disconnects the line. We have different type of breakers. So we have MCB, we have ELCB, we have CBs and the rest. Shall I give you another assignment of breakers? Okay. Shall I give you guys assignment of breakers? We have surge. You know, one shop. You know, one big bad like this. This surge one. In surge, it has inputs. your life and your neutral will enter. It will not supply output. The only output that it has is heart, to the heart. I'll still draw, maybe when we get bored, I'll draw how to connect such. Although I have a video on YouTube where you can see how we do that. Can I move on? How many have I talked about now? Breaker, surge, and in an isolator, the moment you isolate to off, the whole system will remain off. Nothing will turn it on. The moment you put it on, it will also remain on. Nothing will turn it off. You know, in breakers, the moment you notice any error like this, it breaks the circuit and switch off and isolate it. While isolator, on or off. Can I move on? Next, after that, we have the what we call VCR, where you can edit your voltage and your current. I have another video on that on YouTube. Although maybe towards when we go deeper in the class, I will explain it. And when we have site work. In that one, you can decide the VCR. You can decide this is the maximum voltage. Let me say an inverter now. They normally have high voltage there. You don't want high voltage to spoil the inverter. Anytime the voltage is more than 250 volts, don't allow anything.
Where can you edit your voltage?
You can edit your voltage, your amps, and your timing. Shift. I've come. Go in. You can even set timer there. That is, the moment you notice that there is an error, remove the system. After removing the system, if light comes back, wait for maybe 5 seconds. You start seeing it reading 5, 4, 3, 2, and before reconnecting it. You know, there are sometimes where you'll be having fluctuation of light, going up and down, going up and going down, going up and going down. Instead of it to just trip on and going on and down like that, you can put a timer. You can set the timer. You can even set it to 10 seconds. That job that we install 10 panels, that job, use it there. That is after 10 seconds, that's when it connects back. We'll talk about it later, how we use it, maybe input on output. We have another device that I'm holding, under protective device. This one I'm holding here, we call it energy meter. This particular type only work on display. We have the one that use Wi-Fi. We have the one that use Bluetooth. That anywhere you are in the whole world, you can monitor the energy. If you are connecting it towards the panel side, before you reach home, you already know the total wattage that you have at home. So you can know maybe it will reach you or not. But this one is just for display. We normally use this one when we are tracing fault sometimes. If you don't put it in this, you start checking. The moment you notice that there is high energy along any of the wires, you know that there is an error in the system. Imagine you plug the socket. There's a socket, there's nothing plugged to it. And that socket alone is controlled like 500 watts. What will happen to the inverter system? It will drain up. So we also use what? Energy meter. It's part of your protective device. Then after that, we have what we call the protective box. That's like a big box where all those devices will be arranged. You can check my previous YouTube video. And by the time we're having sites to see. How many of you go to that Ikoyi hospital? Who follow them to the hospital when we're doing job? Okay. You see those small box where you put through. That's what our protective box, where you arrange those devices. And if you don't want to put it inside box, we have what we call railings. Protective railings. The one that you bought the other time. You just be hanging those breakers inside the railings. Although people like me prefer the box. But you know there are some clients, by the time you submit the bill, they will be asking you, which one can we remove to reduce the price? Is it box necessary? Maybe it only made the job fine. Yes, it made the job fine. Remove am. Let me use it. Oh, I get what I'm saying. But sometimes when you put it inside box, it makes your job neat. Very, very neat. Let me move to the next one. We have what we call the marine board. Alhaji Abamgbe marine board kan wá. Someone wan ask me online that Mr. Paul, is the marine board
You are done with the
flammable?
protective device.
I'm done with the protective device. We come back to it later. I start explaining them one after the other later. In the board, the major reason why I use the board, I was on a project in Abuja some times ago, and I noticed that my changeover switch, I want to put my charge controller. What do I get what I'm saying now? I have maybe a point for my changeover switch. This one for charge controllers. This one for protective device. In some places where they use energy meter, I want to put another energy meter here or energy timer. No, there was a job like that we did in the Ogbomoso. Because no person stay in that house. They only come there as like a vacation home. So, but the boys quarter, they have tenants that stay there. We now put an energy meter that by so time of the day, maybe around 12,
Anytime, see charger.
Hope you guys are enjoying the class. And if you don't enjoy the class, no problem. Go and buy Aluma. Enjoy the class.
Look, get girl.
Casamprenco.
You own it now.
I know this is over in charge. Can I move on, please? After that one, we have our what? AC cables. AC cable carries our alternating current. Alternating current, what do I say about alternating current? They have a lower current or higher voltage, like 220 volts, 240 volts. Next after that, we have what we call knife changeover switch. Your knife changeover switch. Or let me call it changeover switch. Because you can either decide to use knife. We have the knife changeover switch. We have also what we call the gear changeover switch. And we have the breaker switch. I used it in some job of recent. It was a client that bought it. Those breakers, you know your knife changeover switch, if it's knife changeover up or down. So it's either NEPA or gen. If you are not using solar, you need to buy two. You have another one for gen or NEPA or solar, or NEPA/gen or solar. Am I right or wrong? But there's another switch.
Is there a switch like 3 in 1?
That one was even 4 in 1. So it has a place where you can put your NEPA. You have a place where you can put your Gen 1, Gen 2, and the solar. So it's normally like a normal breaker, your normal breaker. But instead of up and down, you now have 1, 2, 3, 4. So anyone that you pick will be anyone that you switch to. And that one, you can even put it inside your protective device. It will have 1A and B. Or sometimes they will write 1 L and N. L stands for live and neutral. 2 L and N. So you put it inside it. And in that thing, you must not make mistake. One of my boys made mistake that day like this. That breaker burn. Oh, burn that. And as at that time, there was segmented breakers or segmented changeover switch. It's segmented breaker. That's what they wrote on. Segmented breaker. That's what they wrote on that time. It has 1, 2, 3, 4. So you can decide to use in that particular client house. I can't remember, maybe the video is on YouTube or not. He has 2 gen. He has one small gen that he uses when he doesn't want to run AC. He has a big gen that can carry the fridge, freezer, and put on the AC. He now has the inverter and the normal NEPA. How did I get what I'm saying? So you can get that one. That one is not that popular. It's more expensive and more technical. And that thing, you must not make mistake. All they are neutrals. You can even use one neutral for every one of them and look the neutral. But the moment you make mistake and connect neutral as live, don't worry, go and make that mistake. You do not make it twice. You know, I used to tell, I once had a student, anytime he climbs roofs, can I move on? Can I move on?
Yeah.
Where did I stop?
Hey, a student whenever he climbs roof, yeah.
Anytime you enter room, he normally breaks he will either break their asbestos or break their what's it called? It's not fact. I now told him, I said, I had the prayer. I said, one day he will fall from that roof downward. But I'm not only praying that he falls, but when he falls, his hand will not break, his head will not break. The day he falls like this, since that day, he never fall again from it. He became more careful. But for like a week, there's something in Yoruba that they call a rookie. That place has like a mini dislocation there. So for like a week, that hand I used to come down. So that's the same thing about all these things. When you are connecting those wires, you need to be extremely careful. We still even come to panels. There are sometimes when we want to install like 20 panels, I will carry paper tape. After doing the drawing, I will write panel 1, 2, 3 to 20. This is how you connect it. Because the moment you make mistake in one of the connection, it might disconnect up to maybe 1,000 watts. Just imagine you have a system you are setting up that is 5,000 watts and you have already lost like 1,000 watts. The owner of the building will just be complaining, hey, even with sun, this thing is not charging. Your house is not an error from the panel, it's error from your connection. We'll still get to that later. We are still in the introductory class. So after that, I've talked about the changeover switch. I've talked about the marine. We are now moving to, we have the inverter itself. We have the inverter. The average inverter has 3 sections. An average inverter has 3 sections. We have the inverting circuits, we have the switching circuits, and we have what we call the charging circuits. The inverting, the switching, and the charging. We have the inverting circuit, the switching circuit, and the charging circuit. So let me just do the detailed explanation. The charging circuit of your inverter is the one taking care of charging up your battery. The charging circuit of your inverter is the one that takes care of charging up your battery. What's time? As I told you guys that this class is 1.5 hours. So this class should be stopping by 12:40. So we have 16 minutes to the end of this class. The switching circuit is the one that switch between charging and inverting. I will explain it better later. And the inverting circuit is the one that makes the energy that is already on the battery available for use. It converts from VDC to VAC. Just put it down that way. If you don't understand, you understand later. Your inverting part will convert from VDC to VAC and make it available for alternating use.
So if you say charging circuit and switching circuit.
The charging circuit to convert from VAC to VDC and charge up your battery. Let me repeat again. The charging circuit to convert from VAC to VDC and charge up your battery. The switching circuit will switch between charging and inverting. Lastly, while your inverting circuit through your MOSFET and some other devices will convert from VDC to VAC. That is from a direct current to an alternating current and make it available for use. Next after that, we have our batteries. We have different types of batteries. The major function of your battery is to store energy, to make it available for use and reuse. We have different types of battery. We have the tubular battery, we have the lithium battery, we have the hydrogen battery, we have the AGM, we have the gel battery and the rest. But the major function of all those batteries is what to make it work, to store your energy and make it available when you want to use it. Next after that, we have what we call the battery rack. The battery rack is where you position your battery so that it can arrange them properly and do some other functions. And lastly, we have what we call the acting circuit. Like the last job you guys went to do at where you provide what a standard acting system, where you have your thunder arrestor, your acting tape, and other things, so that that inverter and all the systems of your solar and inverter can what be protected from thunder strike or thunder spike. Against our next class, I'll be explaining the difference between the thunder strike and the thunder spike. So at this junction, I'm pausing this class because we are through with introduction. Against next class, we now start taking them one after the other. Maybe we start from panels. You explain panel deep. I give you assignment. Please, it's not necessary you do my assignment. But the moment you don't do my assignment and you are copying the notes here, you are owing us cooking. And from that assignment, we will be able to relate better. Do we have any person that is having a question or question to ask? Question.
My question will be based on the question of this.
When we get to protective circuits, we'll be talking about that. And any other question? Yes. Yeah, we have the DC type. We have the AC and the DC type. But that DC is not as common. It's the AC. You know, most times in this environment that we have, it's normally AC that normally gives us most problem. When your NEPA or your energy generating company will bring one voltage that will destroy everything.
So, AC are mostly used for
AC is NEPA. DC, direct current, and the current coming from your batteries. We talk more about that. We talk more of energy variables again next class. Then later I now talk about load, your electricity, all those things that you are buying in your house. How do they behave? Any other question? So in the absence of no question, thank you very much. Hope you enjoyed the class. So stay blessed.